So example D looks a little bit different in terms of the equation that we're working with. So again, we want to just start by identifying A, P, and Q to help ourselves out. A is still 1. There's nothing out in front. But P is now -1. Okay, so be careful, because remember that original formula is y equals ax minus p squared plus q, which means that in order for this to be positive in my equation, I need two negatives together. So putting in a positive 1 here would have left this as subtraction. I needed to change that sign. So p is -1. There's nothing written out here, so q is just 0. So again, I'm ready to write my vertex immediately from this form. So this is why vertex form is my favorite personally, because it tells me so much just by looking at a couple numbers. So my vertex is going to be at -1 and 0. The axis of symmetry has now officially moved. It's at -1 instead. It's still opening up because A is still positive, which means I'm looking at a minimum when y is 0. So starting at 0 and going upward for my range. Domain is unrestricted, so I've got those. Again, I can solve for my y-intercept as well. In this case, I'm going to go 0 plus 1 squared. Now, because it's inside brackets, I'm going to add first. So 0 plus 1 is 1, squared is actually 1. So whereas when we didn't have a p-value, q automatically took on the y-intercept, and you may have noticed that. The second we have a number in place of p as well, that x value of my vertex is not 0, then all of a sudden that impacts what my y-intercept is going to be too. So y equals 1 in this case. And we'll come back to those x-intercepts. So I'm going to go ahead and I'm going to put my same scale on just so I can kind of compare later on. Starting at -1 and 0. But again, no stretch and compression. So when 1 is squared, it's 1. So that's the pattern I'm going to follow, even though I've moved over. When 2 is squared, it's 4. So that's where I'm going to put them. So 2 away from my vertex. When 3 is squared, it's 9. So 6, 8, 9. And 16 is off my grid. So here is my parabola. And again, you'll notice on all of the graphs that I've drawn so far, I'm very conscious that it doesn't look like a V at the vertex. Please, please, please do not make a V. That is wrong, okay? It has to be curved at your vertex. Also make sure you put your arrows on the ends because it keeps going forever. Now I look at my graph and I say, okay, well, I've got this point right here at the bottom that's exactly touching my x-axis, so I have one intercept. X equals -1. So that's how I graph it when I have a value for p, and that's how that transformation kind of impacts my graph. E is similar. So again, I'd like you to pause the video here and try it on your own. See if you can come up with the correct answer. I'm gonna stall for a second here so you can pause it, have some time, but I will explain how to do it. So if you get stuck, just hit play. So again, we've got A is 1. P in this case is +4 because that negative again is coming from my original formula. And Q is non-existent, which makes it 0. Now you're like, okay, Ms. Conrad, but why is Q 0 but A is 1 when they're both invisible? A is multiplying. If A was 0, that would turn the entire term. All of this would disappear. So we can't have that. We need a seed. We need a place to start from. So we need to start with 1 when we're multiplying. But when we're adding and subtracting, if we're not adding anything, then we're not adding a number at all, so 0 is what goes in there. So that's kind of one thing, one sort of nuance to watch out for, if you've been wondering that. From here, I know my vertex is going to be at +4 and 0. So my axis of symmetry is now at +4. A is still positive. This is still opening upwards, okay? So it means that I still have a minimum at y equals, in this case, 0, because it hasn't shifted up. So my range starts at 0 and goes upward. And my domain is everything and anything we can put in for x. Again, for my y-intercept, I can actually plug in 0 plus 4 squared, and that ends up giving me y equals +16. So again, the only thing I'm going to have to come back to is that x-intercept. Everything else I can figure out just from my equation. That's it. I don't even need to put it on a graph. So I'm going to use the same scale, -1 and 1 for x, and increasing by 2 on my y. This time I'm going to put it at 4 here. But from here, the shape is still the same. I have not stretched or compressed it. A is still 1. So I follow my same pattern, that 1 squared is 1. 2 squared is 4. So I'm up 4 from my original y value of my vertex. 3 away is 9 squared. And 4 away is 16, which is going to be off my graph in this case. But again, we're seeing that same idea. It hasn't changed shape. It's just changed position. We could say it's in we call this quadrant 1. So my x-intercept in this case is going to be x equals 4. I can see that here on my graph. And I'm done. So again, vertex form is super helpful because so much of the information we need in order to put it on graph is given to us right there, already broken down.